Hello, this is Ryan, and I'm back for another video for week 3. This time we're going to talk about section 1.5. So let's go ahead and let's get the presentation downloaded. Okay, so here we go. So this time we're going to talk a little bit about solving other equations. In the last video we talked about solving quadratic equations by factoring 4 different ways. Factoring was one of them. We also talked about completing the square root method, and the quadratic formula. This time we're going to talk about radical equations, absolute values, and factorable equations. So here's your type of equations. You have radical equations, and absolute values, and factorable equations with degree greater than 2. So this would be the index here, or is a 4. Typically, when we do quadratics, those are 2, degree 2. These are degree 4. This is degree 3, because the largest exponent is a 4 here, and it is a 3 here. So, solving radical equations, here's your process. You're going to want to isolate the radical. You're going to raise both sides to the appropriate power. If it was a square root, you're going to square both sides. If it's a cube root, you're going to cube both sides. Solve the resulting equation, use the appropriate method. And for these problems, you have to check your answer. So let's look at an example. So here's an example. So step 1 is to isolate the radical. Notice how we subtracted the 2 from both sides. Now this is a square root, so we're going to square both sides. So by the square and the square root, those are inverses of each other. So by squaring a square root, you essentially remove it. So if I square the square root of 12x minus 2, that essentially becomes 12x minus 2. And then if you square one side, you square the other side. So I square the other side. So I get x minus 2 times x minus 2, which you can multiply that out. And you go down through it, and you solve the equations like you would before. Again, isolate the variables on one side. You get equal to 0. Factor it. So x is equal to 4, and x is equal to negative 2. Now the big thing you got to remember with these radical equations is you have to check your answer. You take your 4 and your negative 2 and plug it back into the original equation and see if both answers work. Notice how the x equals 4 works, but when I plug in negative 2, it doesn't work. 6 does not equal negative 2, so that one doesn't work. You have to cross it out. So the only answer is x equals 4. Now, the next one is an absolute value equation. And you have to remember the absolute value. The absolute value of x. X can be negative or x can be positive. In both cases, when you take the absolute value of a negative number, you get a positive number. You take the absolute value of a positive number, you get a positive number. So here we go. So let's get started on this. So when you solve there's 2 ways to solve absolute value equations. This is the first way. So the first thing you're going to want to do is you're going to want to isolate the absolute value. Just like before with the radical, we isolated the radical. This time we're isolating the absolute value. So to do that, I'm going to add 7 to both sides. So notice how I add 7. So that's where that 10 comes from right here. Then using the definition, you're going to have the positive side, 3x minus 2 equals 10, which is a positive, and you have the negative side, the negative of 3x minus 2 equals 10. So then you solve both of the equations. So you have to do the positive of this and the negative of this, and that's what this is. Here's the positive side, here's the negative side, and then you just solve each equation. Now again, like the radical equation, you should check both sides. You should check both answers to make sure it works. Here's method number 2. This is the one I like to do. So you're going to do the same thing. You're going to isolate the absolute value. You're going to add 1 to both sides. So if I add 1 here, that goes to 0. Add 1 here, that goes to 6. Now this time, I'm going to say, if I think about this last step up here, here's the positive side, 3x minus 2 equals 10. Here's the negative side. If I would just divide both sides by negative 1 first, I'll just skip, and I'll get 3 minus 2x equals negative 10. I'm essentially skipping a step. I know that it's going to be equal to the negative of 10. So down here, that's what I'm doing. I know that 7x minus 11 will equal a positive 6, and 7x minus 11 will equal the negative 6. And do the same thing, solve both equations for x, and then check your answers. Here I show worked out to 3 decimal points. I prefer that you just leave it as a fraction. Don't work it out to decimals. Just leave it as a fraction, but you can do this if you put it in your calculator. But express your answer on your paper as these two answers here. Don't put the decimal form on your paper. Just leave it as fractions. Now, the next one is factorable equations. So, the trick with this one is understanding that x to the fourth minus 4x squared equals negative 32 is very similar to this equation. X squared minus 4x minus 32. It's going to factor the same way. But instead of having an x squared, I have x to the fourth, which means when I factor x to the fourth equals x squared times x squared. So that's where that x squared comes from. Now, when you get down to these problems here, notice how you can use the square root method from the last video to solve both of those. This is a square root method. And again, you have to check the answers. And this one's not real, because I ask you to determine the real solution. So you would take this one out because it's not real. If I ask for all the solutions, then this would be plus or minus 2i is what this would equal. But it's not real, it's imaginary, or it's complex. And don't forget the plus or minus out front. Okay. So same thing works here. Here's another method. It's called the u substitution method. Here we're letting u squared equal x to the third minus 6, x to the third squared, and that is equal to x to the 6. So you just use the u substitution method, where you let x to the 6 equal u squared, and then it factors down just like you would normally do, and you substitute back. When you get to u equals a number, you just substitute the x to the third back in for u, and then you solve it using the cube root method, where you take the cube root of both sides. Here's another example. And then this is one where you get down to where you need to use the quadratic formula on a part, like x squared plus 2x plus 4. You have to use the quadratic equation on that one. So hopefully you like this video. Hopefully it helps. If you need more help, please reach out. Let me know. I'll be more than happy to help you.